Hello and welcome back to another episode of Getting into GiG-28. Welcome back, Sydney.
Hey, Sebastian.
Well, that was an interesting weekend. I hope for you as much as for me. Interesting. Sorry.
Yeah, it for sure was, yes. An interesting weekend.
Yeah. The astute audience will notice a new background, which probably explains part of your weekend anyway. I had the benefit of just staying where I am, hence the same background, and could look into the things we discussed last time a little bit. So I did work on getting the foundations done for what we can use very well today, and I'm quite excited about that. And now for one, I can actually speak like I'm excited because I don't have to keep my voice down as there are multiple meetings in the same room or stuff like that. So let's use the time we have. It's precious. And that's the test we wrote last time, and it doesn't yet use the actual configuration because we
Right.
didn't actually have that. And then we had the conversation about how could that look like. Git config isn't yet available or wasn't available from the handle. It's still called handle here. And then, there was this idea of, okay, but, this differentiation between the Git repository and the Git handle, and can you figure that out? And you were kind of very, I don't know, positive, saying, yeah, once you learn it, it's easy, but everything is easy once you've learned that, if you think about it. So I really took that very seriously and just did a big refactoring. And I think it's best visualized using the stat program, which now looks like this. So there is no mention anymore of a repo. And you just say git discover, and you discover a repository. And then you use the repository like before. And yeah, that's it. It's really just
So
that.
this is not actually the handle like we called it before, but it's just not mentioned anymore in the API. So as a user, you don't really have to care about it.
Yes, by default, you don't have to care about it, but I think there are some sample programs that actually do have to care. Here, is it this one where it actually cares? Ooh. Nah, not really. This code, I think, was written to just, drop a level down to totally avoid this problem entirely. Using, it uses thread local state too, but it avoids Git repository. And it doesn't use the capability that is there and just does everything kind of by hand, which is nice that you can even do it, right? So it's good. That's exactly the principle of Git repository, that it gives you the high level, but also access to the lower level part if you need it. So you drop down only where you need it, or where you decide that you need to shave off 1% of performance or gain 1% of performance if that is an issue, or do something that otherwise wouldn't be possible for some reason. Yeah, but there's no example here. I think to keep it short, most people probably don't need that unless you want to use just par iter here. Maybe to explain a little bit what that is. So try for each init. So that's a parallel iteration, is like a parallel loop. And the operation here is a function that takes, that's apparently the iter mut version, I don't know, that takes a mutable, I don't know what the difference is between self item and the type t here. The t is probably what's iterated over, but whatever that is, doesn't matter. This function needs to be sync. And even init needs to be sync. And the problem with these functions is that even though they're not advertised as mutable, you can't share just a function or closure that is not sync. And this handle here, what's returned with discover, it's now called a repository, but this is what previously was the handle. This one is not sync because it has the ref cell. I think last time we showed that ref cell explicitly declares itself as not sync because it allows interior mutability in a fashion that only works if it's not accessed by multiple threads. And if you want things sync, you then use a mutex or shared ownership with a mutex, and that's a problem. It's something that is of course slow and that explicitly you don't want. You don't want to pay for thread safe primitives in a thread local context. You can't just make it, I mean, you can make everything thread safe, but the whole point is to not do that and be able to choose. Also, this ODB handle here is something that is using ref cells a lot.
Mm-hmm.
So it also has a bunch of args to stay sendable. You want to be able to send this thing to other threads, send it over thread boundaries, but you still cannot access it in a thread safe fashion. So it's not sync either. So the whole Git repository is not sync. So what do you do in a situation where you would like to deal with this par iter? Where was par iter? Okay, probably have to. I mean, you've seen it. It requires sync, and yeah, what do? You have to somehow get. I think I know what T was. Let's go back there. Into par iter, try for each T. Yeah, init, see? So the initialize function returns a T, and the T is the thread local state. This is why it's mutable.
Okay.
And you see how you want to use the init function with something that is sync to produce a handle, or now called Git repository, per thread.
Mm-hmm.
And that Git repository does have shared state. So that shared state obviously is synced like the object database, but other pieces are not, like the caches, the thread local caches for object access and so forth. And you need to be able to put something that is, or have something that is sync and pass it into init so that you can produce a repository that is then passed to each thread accordingly. And there you can just use thread local state as before. And it's kind of a special case because Git repository, Git repository, the Git Oxide create ecosystem kind of avoids that. It just doesn't declare these as sync. It declares them as send plus clone, which means that the function that you pass here for initialization is cloned before it's sent to a thread, which makes the thread local itself. So init is thread local whenever you use Git Oxide parallelization primitives for that reason, just to avoid this kind of awkwardness that happens. But if you have that awkwardness because you want to use Rayon, what do? This is why it was never an option to just say, yeah, we skip the threads, the sync part entirely. We couldn't just remove it and say there is no sync, deal with it. It's only thread local. And yeah, this is why the repo can now do to sync, actually into sync, it's called. So this particular handle or this particular repository, yeah, it's a handle still, at least in my thinking, because clones are cheap and they refer to the same repository. But anyway, and into sync gives you I called it thread safe repository. And thread safe repository is containing exactly the same data, the same shared data as the Git repository does, or the non-thread safe one. Even though it's also kind of thread safe, right? It's like it is thread safe, but it's not sync. So maybe this changes. I did call it sync repository at some point because it's kind of obvious, but then it's like, wait, is this related to Git sync? Is this a synchronization functionality with the Git remote? Can you sync stuff? Is it? Yeah.
So, yeah, that's I guess that's dangerous.
Yes.
It being the Rust keyword and the same kind of word used for Git, yeah. Yeah,
it's, you see why I called it thread safe, but now that I talk to you about it, I feel also it's a bit, yeah, it's okay. It's probably better than sync, but people could argue that the other one kind of thread safe too. But anyway, and it's really just that. And this thing here is sync, and you can convert that into, let's see, let's just call that to sync to thread local. So you can convert that back and forth.
Okay.
Because it's just moving data around, you know, you strip the thread local data off and it remains the data that is shared across threads and that is shareable across threads. And this puts the data back, so to say. And yeah, to-thread local is something that I use somewhere. That's why I have this function. And generally, I prefer these two versions of the methods in order to, you know, not consume the instance itself. It's just more convenient. Because into sync is, you know, consuming. And it's intentionally consuming because I only ever needed the consuming versions of this. But to-thread local is nice because then you have a sync or thread local repository, and in your init function, do I still get that here? No. Okay. In your init function of Rayon, for example, you can then use to-thread local each time when you're called, and you can use the same instance to just create a new
keep going, basically.
Copy for each thread, right? This is why you need, this should be non-consuming here, whereas this is consuming. But in the end, clones are always cheap no matter what. They're cheaper for this one, for the sync version, than the unsync version because no thread local state, but still, you can always clone to deal with this if you want to, but of course it's kind of inconvenient. Yeah, and that's the new world. That's pretty much it. And it feels better indeed. Everything was adjusted already, and that's the way, I think. And that's kind of the last thing that was asking or begged to be changed, and now finally it's done.
Yeah, pretty nice. It's definitely gonna, yeah, it just makes a big change just in the highest level, really. Like, it's easier to get into it, I think.
Yes, I hope so too. You see, I kind of did it quick and dirty. It's still a thread safe repository that does all the things. I just do the conversion there, which is fair, right? You start with the one that only has the shared data and all the data that you need, and then you say, okay, put the thread local data in it now, and that's the into part that produces a Git repository, just using the standard conversion traits of Rust. And that's something you did all the time anyway. It's the same as too easy, which doesn't exist anymore. So too easy is now to thread local, just to highlight really what the differentiation is. And yeah, I think it feels good. Of course, names can change, but the overall API, I think it's now there. And with that, I think we can go back to what we need to do next. Where's the prefix here?
And integrating the config into this repository, basically.
Yes, that's getting this line here to work. And let's see. Yeah, now this is not called handle anymore. So these have a repo reference. And this repo now has a config. And this config is really just, it's just the first step towards really getting into this, but it's good enough to kind of work for this case, I think. At least it would work for us if you write the test for that. And read-only access for now. And even, it's not even public yet because I'm so uncertain about how this is going to look like. So for now, the only stuff I expose is, I think, implemented directly on repo config int. I called it. Let's see, key and the default. So I think the default is usually 8 in typical Git repositories these days, as we have seen so many times with short ID. Is this the right command? Yeah, I think it is. Just the wrong order. Interesting.
Oh, wow.
Yeah. That's command line argument parsing done in C. It's amazing. If you look in the Git source code, they have everything. They have kind of their own argument parser. They have this and that, everything. Yeah, their own string handling, their own path handling to some extent. It's all custom because there's no standard library really in C. And every program you write, you do it from scratch.
Absolutely.
Need a vector? Write one. Need a linked list? Write one. Need a hash map? Sure, you write one. Every time you write the best possible implementation of a hash map.
I guess it's fun, just takes a bit longer.
Yeah. This is where computer science is coming from. I mean, literally, right? Like from C, you have to implement it and you have to know how to do this. Otherwise, you can't do anything, really. So I understand why in many cases you really need this, or companies want this kind of knowledge. But then again, it's like when do you actually get to use that? Unless you write a C program from scratch, mind you. Anyway, I'm not judging. I'm just saying I'm happy that I don't have to write this all the time. I can focus on actually getting stuff done. So yeah, that's 8 as the default here, obviously. And I didn't ever set this last time we checked this as well. So it just defaulted to 8 here. Let's see how this is implemented. Yeah, not very interesting. I also think this has to change, so let's not look into it. It's just a hack basically for us now. And even though this is public, does it have to be public, by the way? I don't think it has to be. Let's just keep this internal for now. And, oh yeah, right. We should probably see things here. Ah yeah, cool. This actually doesn't fail. It can't fail because if we have the config, we already parsed everything. Then we just have to access the data and that does not fail.
What if it doesn't exist?
Then the default
value.
Yeah. So I didn't even return an option here because I didn't want to write unwrap or all these things or map or all the time. I just thought this is the way you use it. And you want a value and that's it, deal with it. And I guess that API will also evolve over time. But for now, for this function, it's the right thing. And it only has to be used here. Right now, let's see, hexlang. Unused variable. Yeah, good idea. Oh yeah. Yeah, that's a good one. So that's the U size, whereas we get an I size. Because people can theoretically provide negative values here. And yeah, good question. What would Git do, right? What would Git do? Let's try. Let's see what Git would do. I think we tried already what would happen if you provide it with a value that is wrong.
Yeah, I think it fails, right? I think, yeah, we can either use a default or fail explicitly.
It fails, yeah. It's interesting because here, this is even infallible, just gives you the defaults. I think also, I think from that point of view, it's wrong, right? You should be able to fail here. I don't know what I was thinking there. I was really going in for it must never fail. It's always working, even though it technically can fail. Yeah, so this should probably be a result then, huh? Let's see, failure modes. Show me the failure modes. Core, abref. What about -1?
Out of range.
Cool. I'm a bit surprised that it's able to say that even. And it says that on the config level. Aha. So I guess even in Git land, it's able to differentiate between signed and unsigned. And you can tell it what you want. And as you query data, yeah, you can give a certain constraints. And I guess at least signed and unsigned is there.
Yeah, so if you were to put 2, then it shouldn't fail.
Oh, I'm impressed.
That's surprising, yeah, because it has to know the range of that exact config.
Yeah.
That's
That's cool. So what happens with that? Too big? Yeah. So on config level, it knows that. But it looks also kind of specific with abref, but maybe that's just a key name. Do I find that in Git directly?
Oh, but I mean, maybe it's still checking that on the call side, right? Where you're trying to get the actual value, and then can just trace it back to this exact config name or property name or whatever you want to call it.
Yeah, here's exactly the code that does it.
Okay.
So I'm laughing because, of course, it's not, it's not really sophisticated. There's just this global value here. And with this global, is this an initdb? No, it's in config C. So that's probably called sometime. And it just sets these variables based on the config and makes them global. And then you just use the value. And the error checking handles here and happens here. It happens once. So that's not lazy at all. Huh? That's, it's not evaluated on use, but it's pre-evaluated. And sometime probably somebody has to call this. And has to call this. There's this, I don't want to digress too much, but I thought it's cool or good to know. There's this initdb, and that really has a lot of the initialization tests that Git does when it starts up in order to figure out what's going on with the file system, for example. And certain environmental questions it wants answered to know what it can and should do. And I would think that maybe here, somewhere it initializes the config. Yeah, it already accesses the config here. So I don't know. Maybe the config access is actually done lazily, so it kind of initializes itself. No, I don't know. That's for another day to figure out where the config is started up. But that looks like it's already very much present and alive here. Yeah, okay, cool. So now we know how that happens. In our case, it would be different, huh? Like here, we would have to add some error return value. We might have something that actually returns or converts that into an unsigned right away. But
how would you, you have to define somewhere what this specific setting is supposed to be, right? You have to, and then you have to do that for every single other setting as well. Like these ranges need to be defined somewhere.
Yeah, we have them implemented already, just differently. So for us, everything is lazy. So here, for instance, I can imagine to say something like try into, and then, you know, here you actually do the error conversion so that you get this prefix error. Oh, interesting. Config open error. I think I kind of half botched this one, so we can definitely put some work into the whole config stuff, because there is no config open error. The config is already open as we're here. But here would say, here we catch the negative value error because try into will fail if it's negative. And here, when we create the potential prefix, we have the out of bounds error because here checks the high bound. Here checks that it's not too long.
Right. Okay, so the try into automatically does a bound check, basically, or just sees if it's negative if you want to convert it from
Yes.
an assigned into an unsigned. Okay.
Yes. And this is inferred here. The compiler sees, you put it there, so it's a U size. So try into wants to try into U size, and then this will fail if the value is negative that we get here, the I64. So yeah, it's different, but I'm okay with this being different as long as it's checked somewhere, because this is not, you know, I don't know. It seems all right for me to do it like this, because we do have these bounds check for a reason. I thought we can use them now, now that they're, now that it's time, instead of putting all this here. We could, of course, have some constraints. And maybe that's the way. Then this one here will fail, and you have some sort of config error, which is maybe more descriptive. Right?
Yeah, but I also really like this idea that you kind of interpret the value while when you want to use it. It's not kind of predefined.
Yes.
It's more like, okay, this is just a name with a value attached, and you want to use it in this way.
Yes.
And it kind of frees it up a little bit more. It just makes it less strict.
Yes. I think now we are basically trying it for the first time, trying an API that definitely is not right. It's just a question, for me, should people use standard Rust stuff to do the conversions and error handling and so on, and also range checking in that moment? Or is it something that is so common that you would want that all the time and you want to make it part of the configuration itself? And I have a feeling that especially for these values here, it might be very common. But also, we can just look into the future and say, okay, how often does Git do these bounce checks here? And is it always a bound check, or is there some, yeah, it's kind of a bound check here. Z compression level, that's integer values. Packed window size. Look, and here it needs to be multiple of something, multiple of page size. So that kind of stuff, if you want to have some constraint system, that, you can, but it's kind of besides the point if you just use it once for one specific thing. And I wouldn't implement this, I'm saying. I probably would not. And the past me would totally have done that, because that's so nice to have some sort of stupid little constraint system that is super easy to think of and super easy to implement. It's just nails on the wall, but also then not worth the time really for us now. So, and look at this.
So we do it on the fly wherever we need it, basically. We do the checks to just make sure it's used correctly.
Yeah, I think so. And look here. It's, something special everywhere. And there's not so many of these in the first place, I think, where there's some special stuff. Some specific strings that you check for, and so on. It's totally, could totally be done to have some sort of constraint system as part of Git config, but I just don't see it even when looking at this. Not enough. But maybe a little bit. Look here now, all the enums here with the different kind of values that you support. Yeah, as I scroll down, I kind of slowly change my mind.
Here you also have it all in one place. Really, it's kind of easy to reason about it, or if you need to look this stuff up, and otherwise it will be scattered a bit more, I guess.
Yeah, you know, to me, it's really the difference between where the error is created. So right now we have two spots where the error is created, which is here and here, for the lower bound and the upper bound, essentially. And here it's basically the negative bound, or the negative domain. We don't want that at all. And here it checks for the actual bound of 4 to 40. And for the, like, if this would be part of a command line application, then of course, probably this would go all the way up, and then it's two different errors for different things. The question is, how often would people actually see these errors? We just intentionally messed it up, and there's only one error for the correct range of the prefix length. And I think that's okay. It doesn't have to, but then it's kind of disjoint from the config where it's originally coming from.
Yeah.
And that's also something.
You have two different constraints, really. You have one constraint that this setting has to be unsigned, and then this, if you want to use this value for a prefix, it has to be in this range.
Yes, but I think what Git does masterfully is to tell you that this is part of a configuration issue, because we would only be flagging configuration issues that put a -1 there. Right? This is something. Hey, that's the wrong one. Yeah, this is something we can catch, and that's still, yeah, even that would not be part of the configuration, because we get the config, and then we transform it, and then it's totally lost that it's part of the config. So if you wanted to do this right, then we would have to attach some context here that says, oh, it's part, you know, we try to read this, and we can do that. There is, yes, is there? Hello, hello. Oh no, there isn't, because it doesn't even return a value, result yet. But there would be, I think here that's the case. Context, see? And this is how you can attach some string that further describes what's going on. And maybe that's something we can also do, instead of kind of making this part of this config error. But then you have to do it all the time. Huh? Then you have to know, oh, I'm reading this, so I have to be very, very careful about what's coming in here and have to be good with my errors. And then even then, it probably wouldn't be as unified as what you get with Git here, because it's kind of using the same system. And I guess, yeah, I still don't want to implement a constraint system, kinda. But maybe let's get started with something. Does it even work? Does it even read this? Try into. So now a test should fail. I just do it like this. I just want to see that something is working.
Mm-hmm.
And we can ease it in and try to use the easiest way possible, which means no constraint system, but good error messages. And that could be then even becoming some sort of directive for Git repository, so that people who implement things that are reading from the Git config, that they would be aware of this and handle the errors accordingly. That's something I can imagine. Okay, cool. So now it's already defaulting to the value 8 here, which means that our test does not work anymore. It jumps there, that's nice. Yeah, pre-configured. So that's the default value. So now, ideally, we have some repository that actually sets the config value to something.
Yeah.
So yeah, we can't yet write values yet. And we can't yet write values with git config. It's kind of there, but also not yet. I think it's gonna evolve sometime. So maybe with this, there is a chance. Work tree dear. Okay. To thread local, interesting. Interesting, these functions here, these functions, they still return the original thread safe repository. I probably never adjusted that and just went towards the direction of the least resistance. That's fair. These tests, they also always want a Git repository. They don't care about the thread safe repository at all. So something that can be cleaned up at some point. Yeah, so I'd say find a way to now run git config here and set that value. And one way to do that is to just say, let's have a command that we call git and say the current directory should be the work tree dir. Interesting. Apparently IntelliJ does not know what work tree dir is, even though I think it's pretty clear. Yeah.
Should be.
Should be. Don't know. And then args. That's an iterable. And let's see, maybe iterator is implemented on a tuple as well. Then we can say config set. I don't know. What is it? Git config set for core abref 5? No. Yeah, I never remember that. Maybe add unsaid. Gosh. Do I have to just specify what type it is? Int 5? Okay. Is that... Did that work? It did. Okay, cool. So int core abref 5. Let's see if that compiles at all. Oh yeah, right. I guess that's the first one that really wants to be converted here. To use git repository instead. Then we can do it like this. And I will probably break a few things. Ah, look, see, this mapping just exists because of the thread local thing. That can now also go away. That whole function just exists because of that. Okay, it exists for that parameter as well, so we can keep that. And into iterator is not implemented for a tuple.
Vector then?
Yeah, an array, maybe that works, should work. Oops. Maybe that works. Okay. An array of 5 things. And we didn't do anything yet, so still have to call it. you know, the Rust way of spawning commands is actually, or of starting other commands is actually pretty nice. Once you understood that you have this builder pattern for, you know, setting it up, okay, that's normal. But then how do you start it? And there are just 3 or 4 different ways of starting it. And status says, I just care about whether it works or not. And std out, std error, you can put that way you want, which is usually terminal or whatever else is connected to your parent process. And this is exactly what we want. We don't really care. It should work. That's what we care about, but the rest we don't. Set core average value successfully. First time I do this, by the way, because I really have no other way of setting this. Sometimes what you see me doing is to copy the script and then add one more line there. That can be wasteful, and nowadays I don't do that anymore. If I can, and I just call another git command and make this writable, which sometimes is also expensive. So you have to choose. Either you have some extra read-only thing that is mostly copy-paste of what was there, or you pay each time you call or you run the tests by copying potentially large amounts of files around. Because the RW version of this is expensive because of the copy that has to happen. The read-only one generates or calls the script once and then keeps the folder around on disk. So then, yeah, it's read-only. It reuses what was there. So that's really what usually is preferred. Okay, anyway, so now what to do? Call this again. And see if the configuration is stuck. Yeah. Okay. Let's see if that works. Assert. So
Okay.
that is unexpected. Did I write that incorrectly or something? There's a typo in there. Core airbrush. Ah, yeah, right. Yeah, it's a snapshot. It didn't pick up the new value yet because we parsed the file once.
Right. True.
Yeah. So, yeah, that's also a shortcoming of the current implementation. There's no file system events. It will not recognize if something changed. It will not try to refresh stuff if a value isn't there, because values don't really have to be there. I don't really know how Git does it either, actually. Maybe it uses file system events to try that, and then gets notifications as something changes on disk. But even if this implementation could do it, they're still asynchronous, right? So if I just change something here, that event probably isn't ready as it, that quickly. So yeah, how do I refresh? How do I refresh this? Jeez. I really need a new repo here. So git repository open work tree dir path So work2d is our temp dir. That should contain a Git repository directly, and it should be possible to open this, and that will parse the config file.
Okay, so yeah, okay, when you implement this properly into git config, then this would probably be part of it somehow, right? To kind of notify the repository that it's been updated or something has changed there.
Yes. So I don't have a plan for this yet, to be honest. This is really just for the long running, for servers that would be interested in that, or maybe user interfaces as well. Probably, but then how often does that config change? But yeah, file system events is probably something that has to happen at some point. Okay, so now I've got this ID that is still bound to the previous instance, and now we recreate it entirely just to get the config and detach it from that previous one, attach it to the new one. And there we go. Now it should work. And it does. Oh, interesting. Wherever we go, it seems like it's the first. Like, yeah. Git config is a first, there's no doubt about it, and it's really, really rough, but it also feels really, really rough. And I always think, wow, we can probably get so far now, but it's once again figuring out the nitty-gritty details about how to do stuff. So the next thing, let's think about value conversions here and not unwrap. So config can't fail right now, so we'll just remove this. Or maybe I leave it. It's more like the question of what this is going to be. It's not going to be a value conversion. I don't, it's kind of a first for me to try this with a context. So what I would like to do, maybe I shouldn't think so complicated. Actual config core config value. So the actual value was this, and then we can talk about it and just describe what the value range should be. The minimal we know, the max range we can provide. And so annoying to think about this. Like here, the value could be negative, and we could convert that value here, and here we would throw away that potential prefix error entirely. This one we would simply not use and convert it into this one, which tells you the desired range. And that's what we can do.